Hello everyone. Today I am going to start a new subject, chemical reaction engineering, and this is a very important subject for a gate point of view or industrial point of view. So let's discuss. Today I'm going to talk about the overview of chemical reaction engineering. Every industrial chemical process is designed to produce economically a desired product from a variety of raw materials through a succession of treatment steps. What we have raw materials, right? And which goes to the physical treatment step or physical treatment. Physical treatment means screening, grinding. All these physical treatments you have studied in mechanical operation, subject mechanical operation, and after that we after the physical treatment we put them, whatever we get from here, we put them into the chemical treatment. Once that material is chemically treated, then again whatever we get from here, we again put them into the physical treatment, right? And then finally you will get your product, right? And some of the if some of the product material is not treated completely, or it is not converted into the product, again we recycle and it again reaches to the first step. A typical chemical process, right? And for any chemical process we need two information which we needed to predict what a reactor can do. This is called performance of equation, or we can say performance equation, right? So what is happening over here? This performance equation is relate to input to output. Okay, so let's take, this is your reactor, right? And this performance equation is related to input and output. So we have input here and we have output. Okay, so this performance equation is related to input to output. Fine. Now in the reactor, so what information we needed in the reactor? The first one is contacting pattern. The first one is contacting pattern, and second one is kinetics. Okay, and second one is kinetics of any reaction, right? Now contacting pattern means how materials flow through and contact each other in the reactor, how early or late they mix. So this is the study of contacting pattern. And kinetics, we know that what it means. Kinetics means how fast things happen. If it is very fast, then equilibrium tells what will leave the reactor, and if not, if it is not so fast, then the rate of chemical reaction and maybe heat and mass transfer will determine what will happen. Okay, so these two information we are very important for any chemical process. Now let's discuss what is the meaning of, we know that what is the equilibrium or equilibrium constant. These things we have already discussed in thermodynamics. Now let's discuss what is the meaning of rate of reaction. So rate of reaction is what? It is the speed at which chemical reaction takes place. Chemical reaction takes place, and it is defined as proportional to the increase in the concentration of a product per unit time and to the decrease in the concentration of reactant per unit time. Okay, so these things are very important and we will discuss rate of reaction in our today's video. So before starting rate of reaction, let's discuss the reactions. Or we classification of reaction. So we simply classified reaction in two categories. One is the homogeneous system and heterogeneous system. So a reaction is homogeneous if it takes place in one phase alone. So homogeneous, single phase. Homogeneous means single phase, and heterogeneous means system or heterogeneous system if it requires more than one phase. Okay, at least it requires at least two phases. Okay, requires at least two phases. Action, we know that when a component loses its identity to form a new identity. Okay, so chemical reaction can be following types. First one is decomposition reaction. Decomposition reaction, when a big molecules breaks into two smaller molecules. So let's take the example of, here you can say, when a big molecules break breaks into two smaller molecules, right? Example, electrolysis of water. Electrolysis of water. So what is this? 2H2O, and it gives 2H2 plus O2. Then second one is synthesis reaction. When two or more smaller molecules combine together to form a big molecules, right? It just opposite to the decomposition reaction. That means we have A plus B and it gives you AB, or C plus O2 gives you CO2. So this is the synthesize reaction. And third one is isomerization reaction. So what is isomerization reaction? When molecular structure of the molecules is changed without being combined or decomposed, right? When molecular structure of the molecule is changed without being combined or decomposed, right? So this, let's take CH3, CH2, CH2, CH3, and it gives you CH, CH3, CH3 and CH3. Okay.